Hello everyone, good morning. So we're going over 1.4 today. Last time I start for B8 equations, how to solve a basic equation. We start talking about linear equation. I gave definition of linear equation. Also, I gave some example for how to solve some linear equations. Today we're going over 1.4 solving quadratic equations. Solving quadratic equations. 1.4 solving quadratic equations. So any idea about a quadratic equation? What is the meaning of a quadratic equation? Did you hear about this definition or this word in high school? Quadratic equation? Yes, go ahead.
A
Diane.
quadratic equation is an equation which has a exponent in it and a variable symbol.
Like what? Can you give me like what is the definition or how is the form of the quadratic equation? This is correct, but can you like
It would be
yes.
example x squared plus x plus let's say 1, right?
Okay.
Equals another number.
Yeah, this is correct.
But x squared plus 2x equals -1.
Exactly. So I can define it as in general, like in general, this is correct. This is like some example of a quadratic equation, but I'm going to define it in general is an equation of the form like ax plus bx plus c equals 0. I mean ax squared plus bx plus c equals 0. Here x squared. So here is an x squared. So an equation of this form is called a quadratic equation. Ax raised to the power 2 plus ax plus c equals 0. Okay, so but here we have to know a and b and c, all of them are real numbers. So we have to know also all of a and b and c, all of them are real numbers. So here a and b and this c are real numbers. Real numbers. But also we have to know this a not equal 0. Also we have to know and a not equal 0. Why a not equal 0? Why a not equal 0? Do you know why a not equal 0?
Because then it wouldn't cause a curve.
No, I mean like why this a not equal 0 here? Suppose it's equal 0, what I get? If this
And then
a
if
is 0.
then it becomes, the whole term becomes 0.
Exactly, but no, I mean a, not the whole terms. Like, yes, this term only will be 0. What I get like?
A linear
I will get bx plus c, right?
Yeah, a linear equation.
Linear equation, exactly. So this one a, if equals 0, suppose a equals 0, so I will get bx plus c, bx plus c equals 0. And bx plus c equals 0, this is a linear equation from last time. So will not be a quadratic equation. That's why here a is not equal 0. So a and b and c, all of them real numbers, but a is not equal 0. So this is the quadratic equation. This is the quadratic equation. And also we have to know also a property said the zero product property. Also we have to know the zero product property. So here, zero product property. The zero product property said if I have A times B, if I have A times B equals 0, if A times B equals 0, this implies, or if and only if, implies A equals 0 or B equal 0. Again, if I have two terms, A, B equals 0, this implies A equals 0 or B equals 0. And the same things from this side to this side. If A equals 0 or B equals 0, this implies AB equals 0. This property said, this is called the zero product property. Now, I'm going to starting for solving a quadratic equation by factoring. So we have so many different ways to solve a quadratic equation. I'm going to start by factoring. So the first things we have to know how to solve a quadratic equation by factoring. So here, there's different color. Cool. So we're starting by solving a quadratic equation by factoring. So this is the first way for solving a quadratic equation. We're going to solve it by factoring. So example, I'm going to explain this by example. So the first things here, example. Suppose I have the quadratic equation x squared. Here I have x squared plus 5x here I have x squared plus 5x equal 24. So what is the first step here? How can I solve this quadratic equation? Any idea?
You would subtract 24 to get 0 on the right side.
This is correct. So first of all, when you see something like that, x squared plus 5x equal 24, I have to move everything to one side and I make the other side equal 0. So to move everything to one side, I'm going to subtract the 24 from this side to make this side equal 0. So minus 24 from both sides. This will cancel each other here, cancel out. 24 cancel out. Here I get x squared. Now my new equation. So I have to rewrite the equation as x squared plus 5x minus 24 equal 0. Now, what is the factor of this quadratic equation? I'm looking for two numbers. The product of these two numbers is minus 24, and the sum of these two numbers is 5. What is this number?
Negative 3 and 8.
Negative 3 and 8. Negative 3 times negative 3 times 8 is minus 24, and 8 minus 3 is 5. This is correct. So here I can set x minus 8 plus 8, sorry, and x minus 3 equals 0. Now we have to use the property, this one, zero product property. If I have A times B equals 0, A equals 0 or B equals 0. So this is my A and this is my B. So by using zero product property, so here I have x plus 8 times x minus 3 equals 0. So this implies, what this implies, this is my A and this is my B. What I get now by using the property?
You get negative 8 and positive 3.
Exactly. So I have to write x minus 8, x plus 8 equals 0, or this term x minus 3 equals 0. So to solve this one, I have to subtract minus 8 from both sides, and here I have to add 3 for both sides. Why I have to subtract? Because I need to cancel the 8 from this side. I need x equal, the value for x. So x equal negative 8. Or here I have to add 3 for both sides, so I can get x equal positive 3. So the answer, the solutions for this quadratic equation, x equal 8 minus 8 and x equal 3. Is it clear? Is it clear how we can solve this quadratic equation?
Yes.
Any question? So here I have another example. Example 2. The example is solve the quadratic equation by factoring. Solve by factoring. And the question is z square equal 4. So again, what I have to do here? What is the step?
Since n is positive, I mean, you can factor or you can just square root both sides. And since the n is positive, just take the positive. You don't have to take a negative.
So
Square
I
root
would
both
like,
sides.
no, I mean like, I would like to use the steps like before, like the steps.
Ah,
So
then you
what I
just
should do-
subtract 4 on both sides.
Yes, correct. So I have to subtract the 4 from both sides. So minus 4. Why? Because I have to move everything to one side and the other side is 0. So 4 minus 4, they cancel out here 0. So now I get z square minus 4 equals 0. What is the factor for z square minus 4? This is
X z
difference
plus
of
2.
square. This is difference of square. Yes, go ahead. Show.
Z plus 2 times Z minus 2.
Z minus 2 times Z plus 2 equals 0. Now I have to use this property, zero product property. What I can get here?
Plus 2 and minus 2.
Yes. So here I can set Z minus 2 equals 0, or Z plus 2 equals 0. Now I have to add here 2 for both sides. Why? Because I need the value for Z. So add 2. Add 2. Here I have to subtract 2. Subtract 2. So this cancel out, this cancel out. So the answer is Z equal to, or actually this is correct, Z equal -2. She said Z equal 2 or Z equal -2. This is correct.
These two solutions simply means that if you plug in any of those two numbers in the original equation, you would get 0, right?
Exactly. But in the quadratic equation, all the time the solution are correct. But if you want to check, just like you said, plug inside the equation, Z equal 2, here 2 square, they give me 4, and plug the Z equal -2, -2 times square, they give me 4. So both of the answer are correct. This is right, sure. Okay. Any question for this example? How to solve a quadratic equation by factoring? Okay. Now we're going, there is another way to solve a quadratic equation. So the first one here by using the factoring. So we move everything to one side and the other side is 0. Then we factor the quadratic equation. Now we have another way to solve the quadratic equation is by using the quadratic formula. So here, solving quadratic equation by quadratic formula. Yeah, this is correct. Schaub said in linear equation, there is one solution that make the equation true. And in the quadratic equation, there are two solutions that makes the equation true. But in a quadratic equation, sometimes we have only one solution because the other solution is repeated. So also they make the equation true. The degree of the expression represent how many solutions there are. Exactly. If I have like x squared, we have two real solution. It depends. It depends. Sometimes in degree 2 has no solution. Sometimes we have one solution. Sometimes we have two solutions. But you have the correct things here. The degree of expression represent the highest, not how many solutions, the highest number of solution. So if I have x squared, for example, the highest number of solution is 2. If I have x raised to the power 1, the highest number of solution is 1. So it could be no solution, and it could be one solution for the linear equation x to the raised to the power 1. And for x raised to the power 2, it could be two solution, could be one solution, and it could be no solutions, 0 solutions. So, but you can hear the correct for what Schaub said, the degree of the expression represent the highest number of the solutions. So here, for example, this solving quadratic equation by quadratic formula. So suppose I have a quadratic equation if, so here I can set if I have a quadratic equation quadratic equation like ax squared plus bx plus c equals 0. This is my quadratic equation, ax squared. So now the quadratic formula, ax squared. So the quadratic formula this quadratic equation is x squared x equal minus b
Plus minus
or plus minus square root of what?
b squared minus 4ac
Exactly.
2a.
B squared minus 4ac over what?
2a.
2a, exactly. So what is a?
A is the number.
Coefficient.
Oh yeah, the coefficient, right?
Coefficient of x squared. This is my a. What is b? The coefficient of,
The middle term.
yes, exactly, the middle term, or coefficient of x. And c, the number here. This is C.
Constant.
Yeah, the constant number. So the formula is x equal minus b, the coefficient of the middle term, plus or negative square root of b squared minus 4 times this a times this c over 2 times a. But we have to know before doing this to solve the quadratic, to solve the quadratic equation by this quadratic formula, we have to know, we should check first the discriminant. So let me give you the discriminant. Before you use this equation, you have to check something called the discriminant. We should to check the discriminant. So the discriminant equal, called, we denoted by d, so is d equal b squared minus 4ac. This is the discriminant, b squared minus 4ac. So here b squared minus 4ac. So this is the discriminant inside the radical. We have to check this before we start using the quadratic formula. So actually, this is the discriminant. This one. You see b squared minus 4ac. This is my d. This is the discriminant d. We have to check this one. If d, so what I have to check, what I have to set here. So here, if this d is, so if this d is greater than 0, I mean positive number, so then the equation has two different real solution.
If it's a negative, it's undefined, right?
Yes, no solution. So if d now equals 0 again, if d, this d, then has then the quadratic equation. Then the equation has only one, has exactly one real solution. But if this d is negative, so no solution. So if d is negative number, less than 0, then the equation has no real solutions. No solutions. No real solution. So we have to check this d. If this d is positive, so we have two different real solutions. If this d is 0, so we has exactly one real solution. If this d is negative, so no real solution. So before we starting and using the quadratic formula, we have to check these things before everything. D equal b squared minus 4ac. Okay, example for this. I'm going to give example, and I will show you how we can use this property to check before we start solving anything. So number 1, number 2, and here number 3. So example. So the example by using the quadratic formula, solve the following. So we're going to use the quadratic formula to solve the following. I mean, for the following is the quadratic formula, the quadratic equation. So here I have x squared. So I have x squared. X squared plus 4x minus 1 equals 0. So again, to solve this one, I have to check d, the discriminant. What is d here? Here I get question. You use the quadratic equation when you cannot factor. This is correct. Sometimes I cannot factor, so I have to use this quadratic equation.
The d here,
Quadratic formula. Yes,
the
go
d
ahead.
here is gonna be 4 squared minus 4 times 1 times minus 1.
Correct. So let me write the formula for d, b squared minus 4ac. And what is a, Shop? What's the value for a?
A is uno.
1. So a is 1. And what is b?
B is 4.
Is 4. This is b. And what is c?
Negative 1.
Negative 1 is not 1 positive. It's negative 1. Now you plug these numbers inside the formula, b squared minus 4ac. So I get, who will help me? How we can do this? Another student. I need another student to solve this one. How we can do this?
You just substitute the numbers.
Inside, yes.
You'd be 4 square minus 4 times 1 times negative 1.
Correct. 4 squared minus 4 times a is 1 times my negative 1. And what I get?
16 minus 4 is 12 times that is what, 11? I don't know. No, 12.
16 plus
22. Is it?
4 times square is
16 minus 4 is 12. 12 times minus 1 is minus 12, negative 12, isn't it?
No, no, this is not correct. You should to multiply this side first. Minus 4 times 1 times negative 1, I get positive 4, because here I have minus 4 times 1 is negative 4 times negative 1, I get positive 4. Now I add 16 to 4, they give me what? 20. Because the multiplication is more stronger than subtraction. So we have to multiply first, then we subtract. So actually we have negative 4 times 1 times negative 1, they give me positive 4. And then we add 16 plus 4, they give me 20. Now, what is that 20? What do you mean for 20? The discriminant here is positive, right?
It means it has
It's
two
positive.
real solutions.
Exactly. We have two real solutions. The first property, if D is positive, then the equation has two different real solutions. So what is the solution? I have to use this formula. Who will help me for using this formula? Another student. I need some student to help me for this formula. Ahmed, would you like to do it?
Sure.
Ashley, yes, go ahead.
Okay, so we put negative 4.
Negative 4
Yeah,
plus negative.
plus or minus square root of 4 squared minus 4 times 1 times negative 1.
What is that?
That's
Is D, right? What's B squared minus 4 times A times C? What is the value of? This is D, right? It's 20, exactly.
yeah,
We already did the D is 20. So just substitute 20 here. Over
over
what?
2 times 1, which is 2.
It's 2. 2 times 1.
It's 2.
2 times 1 is 2. This is correct. So here I get minus 4 plus 20. What is that? How can I simplify this square root of 20? So actually I have square root of 20
Wait.
is equal square root of what?
2 times 10.
4 times what?
Oh, 4 times 5.
5. 4 times 5. And this is equal square root of 4 times square root of 5. And what is the square root of 4?
2 square root of 5.
Exactly. So actually this value here is 2 square root of 5 over 2.
Sorry, can you go back real quick?
Where? To the previous slide?
Yes.
Okay, give me just 1 second after I finish this one, please. And I'm going back. So now I can simplify it more by dividing both sides by what? By 2. So I should to factor here. What is the factor for the numerator? It's 2, right?
Isn't that negative 2?
It's positive 2. I prefer to make it positive. It's correct negative or positive, but I prefer to put it positive. Now, what's remaining here? Minus 2, because 2 times minus 2, they give me minus 4. Positive, negative, square root of 5. Everything over what?
2.
Over 2. So I can cancel 2 with a 2. And the final answer is minus 2 plus negative square root of 5. This is x. So I can set here x1 equal -2. I take the positive here plus square root of 5. This is the first solution. The second solution, x2 is -2 minus square root of 5. This is the second solution. So actually I get two different solutions. This is the first solution and this is my second solution. Why? Because the discriminant here is positive. So this is the first solution and this is my second solution. Any question before I go back to the previous slide?
I have a question.
Yeah, what's your question?
So you see, like, for the second step that you did, +2, yeah, right there. Where did you get that 2 from? It was,
I factor the numerator.
oh, okay.
So I factor this one. The factor for this one is 2, open parentheses. The remaining here is -2, and the remaining here positive negative square root of 5.
Okay.
Okay.
So-
Now here in the denominator is 2, so I cancel the 2 with a 2. The only solution here, x equal -2 plus negative square root of 5. Any question?
No.
Okay. Here is the previous slide. It's fine, no problem.
Yeah, I get it. No, thank you.
You're fine? Okay. Again, any question for this example? How we can use the quadratic formula? Okay, another example. The same thing by using the quadratic formula. Example number 2. The question is solve by the quadratic formula. The quadratic formula here is x1/3 x squared minus 2x plus 4 equals 0. First of all, we have to check what before using the quadratic formula?
The discriminant.
The discriminant. What is my a here?
1/3.
And what is b?
-2.
And what is c?
4.
4. Now, the discriminant equal b squared minus 4ac. Just plug this thing inside the formula. B squared, I get -2 squared minus 4 times a. A is 1/3 times c. What is c? Is 4. So can I get here 4 minus 4 times 4, 16/3. 16/3. And the answer here, after I make the denominator equal here, is over 1. So I have to multiply both sides by what? By 3 to make the denominator are equal. By multiplying both sides by 3, I make both of the denominator are equal. So now I get 2 fractions. The first fraction is 12/3 minus 16 over 3. And what is the answer here? What is 12 minus 16?
Negative,
What is 12 minus 16?
-4.
Negative 4. This is correct. So negative 4 is equal negative 4 over 3. So the discriminant here, what is the value for the discriminant? What's the sign for the discriminant?
Less than 0.
Less than 0. What does that mean?
We're gonna have only one real solution. Actually,
Less
no,
than 0,
It
the
has
equation what?
no real solution.
No real solution. So no, we don't have any solution. No solution. No real solution or solutions. No real solution. No solution because the discriminant less than 0, negative. So no solution for this one. Make sense? Any question?
Yeah, so does this mean we're gonna stop here or do we continue?
We have to stop. We
Oh,
cannot use the quadratic formula.
okay.
Yeah, we
So
have to
do
stop.
we have to- sorry.
Yes, go ahead.
Do we have to like find other ways to solve it or like this is we stop, like we stop?
We have to stop. No other way.
Okay.
We have another way for not real solution, but our book talk about real solution, real numbers. We have complex numbers. We can solve it in different way in complex numbers, but the book talk about real numbers. So we're going to stop. We cannot move. So you have to set no real solution. Then we stop. Now, suppose I have a simple quadratic equation. So if I have like simple quadratic equation like this, if I have simple quadratic equation as if I have simple quadratic equation like as x squared equals c. This is simple quadratic equation. Just I have x squared equal real number c. If I have simple quadratic equation, then the solutions, I can find the solution right away. The solutions are x equal the square root or the radical for c of c, or x equal the minus radical of c. So again, if I have a simple quadratic equation, x squared equals c, then the solution are x equal the radical of c, or x equal the minus radical of c, the minus radical or square root of c. So if you see any equation like this, you can solve it right away. So we saw some example in the previous, like in the second slide, I think, a question for like simple quadratic equation. But let me give you another example, or we're going to solve the same one. Then I'm going to give another example. So the example is here. This one, z squared equal 4, is a simple quadratic equation. We don't have to solve it like this. We can solve it right away by using the property. So the example is, suppose I have z squared equal 4. So this one is a simple quadratic equation because I have a variable raised to the power 2 equal number c. Then the solution are the variable equal the square root of c, or the variable equal the minus square root of c. So the solutions are z equal the square root of 4 or z equal the minus square root of 4. What is the square root of 4? 2. It's correct. Or z equal the minus of 2. Done. Example 2. If I have Shop said there are two solutions, simply means that x-intercept on a graph. This is correct, yes. The x-intercept on a graph, but this is in the 3rd chapter of this book. We're not going to talk about this right now. So I have another example is x squared equal 9. So the solutions, what is the solution for this one by using the property?
The solution is square root of 9, comma square root of negative square root of 9. So that's 3 and
Exactly.
negative.
This is correct. So the solutions are square zx equals square root of 9 or x equal negative square root of 9. So what is the square root of 9?
3.
3. Correct. Or exactly
Negative.
x
Negative.
equal negative 3. This is the two solutions for this simple quadratic equation. This quadratic equation, this property, we're going to use it a lot. Also, and the other way for solving quadratic equation. I'm going to give another example. Example number 3. So here, example number 3. The example is different a little bit. So the example is solve x minus 4 everything square equal 5. So this equation again is close to the simple quadratic equation. Look, x squared equals c. Something raised to the power 2 equal number. We go back here, x minus 2 raised to the power 2 equal number. So the same steps we're going to use. So I can set here the solutions. X minus 4, this one equal the radical of 5, or x minus 4 equal the minus square root of 5. Same thing exactly. But we need the value for x. What we have to do? We need x equal. What we should to do now?
We should add the 4 on both sides.
Exactly. We should to add the 4 for both sides. Add 4 here, we add 4 here, we add 4 here. Now the -4 and +4, they cancel each other, and the same thing here. So the final answer is x equal 4 plus square root of 5, or x equal 4 minus square root of 5. Done. So this property is very important property. We can use it a lot in the simple quadratic equation, just by taking the square root for both sides of the equation. Now, after we finish, the first step is how to solve a quadratic equation by factoring, and how to solve the quadratic equation by the quadratic formula. Now we're going to learn how to solve the quadratic equation by completing the square. So we're going to learn the third way for solving quadratic equation by completing the square. So here, solving quadratic equation by complete square. Okay, so how we can do this one? I'm going to give the step how to find the how you can complete the square for any quadratic equation. So here I can say to make the x square plus bx perfect square just we have to add only one thing. The thing is this b over 2 square. We had to add b over 2 everything square. So after I add this value,
right?
after I add this thing to this quadratic equation, I will get, so now x square plus bx plus b over 2 square. This will give me a perfect square like x plus b over 2 everything square.
It's gonna give you a nice number.
Yeah, x plus b over 2 everything square. I'm going to give example how we can solve a quadratic equation by completing the square by adding b over 2 square for both sides to solve equation, and I get perfect square like this. So the example now, here example 1, solve the quadratic equation by completing the square of for the following. So the example is solve the quadratic equation by completing the square for the following. The equation is x square minus 8x plus 13 equals 0. I'm going to do this one step by step to show you, because this is new for you, to show you how we can complete the square. So first of all, we have to move the number to the other side and make the variable on one side. So one side for the variables x squared and x, and one side for the number. Yeah, sorry, can you go back? Yes, here. Okay. So again, I have to move the numbers to one side and the other side variables. So how we can move this 13 to this side?
Subtract 13 on both sides.
Yes, we have to subtract the 13 from both sides. So this will cancel out. Now I will get here x squared minus 8x equal minus 13. Now we have to complete the square. So what we should to add?
B over 2 squared, which is negative 8 over 2 squared, which is 16.
Exactly. So we have to add b. What is the b here? Is minus 8 over 2 squared for both sides. Then we have to add minus 8 over 2, everything squared. What is minus 8 over 2? Is b over 2, everything squared is equal minus 8 over 2.
Sometimes you're gonna forget to add it on both sides. It's a
This
tough
is
one to
wrong.
remember.
This is wrong. If you forget to add
Yeah.
the both to both sides, this is completely your answer for the question will be wrong. So you have to add it. I mean, if you add it to one side only, so you should add it to the both side, the number. Now, minus 8 over 2 is minus 4. Square is 16. This is correct, Mohsena. Yes, 16. This is correct. So when I add, I have to add the both sides 16. So I get here x squared minus 8x plus 16 equal minus 13 plus 16. What is the value of minus 13 plus 16?
Wait, hold on. Where'd you get 16 from?
From this one. Minus 8 over 2 is minus 4. Minus 4 square is 16, positive.
Wait,
Oh,
what's
so
the
you
point?
solved the then in the parentheses before you square it?
Yes, again, minus 8 over 2, how much?
Minus 4.
Over 2. Minus 4, this is correct. Minus 4 square, what is the value? Minus 4 square, what is the value? Exactly, it's like minus 4 times minus 4. Minus times minus is positive. 4 times 4 is 16.
Yeah.
So I
was
add
just
16.
confused because I thought we
Wait.
had to do I thought we had to square minus 8 and then square 2.
No. Oh, yeah, this is also correct. If I square the minus 8 square and minus and the 2 square and divide both sides, I will get the same answer.
Yeah.
But I prefer to do everything inside the parentheses. Then you square it is easier for you.
I have a question.
Thank you.
Yeah, what's your question?
What's the point of doing this b over 2 squared if you already have the c, which is 13?
Yes.
Don't you only do the step like if you're missing the c?
Yes. So even if you have a c, the value, the number here, 13, even if you have c, we do this one because the question asked me to solve the quadratic equation by completing the square. So to solve it by completing the square, we have to add b over 2 square. And when we add these things for both sides, I will get a perfect square. I mean, for perfect square, something like this. X plus b over 2 square. And this, I can solve it like this. X minus 4, everything square equal 5 by the simple quadratic equation. Again, the goal for adding b over 2 square to get a perfect square. I mean, for perfect square, something like this, x plus b over 2, everything square. Then when I get something like that, I can solve it by this example, simple quadratic equation. So let's continue doing this. I will show you more details by doing this example. Now, what's the perfect square for this one? What is the factoring for x squared minus 8x plus 16?
X plus 4 and, oh no, x minus 4 and x minus 4, I think.
Yeah, x minus 4 square. This is equal x minus 4, everything square. You see, Ahmed? So now I get the perfect square from this side. X squared minus 8x plus 16, they give me the perfect square is x minus 4, everything square. This is equal minus 13 plus 16. What's the value?
Positive 3.
Positive 3. Now look, x minus 4, everything square equal 3 is the same as this. And this is a simple quadratic equation. I can solve it as taking the square root of c, the minus of the square root of c. So I can solve now here
So
by the simple quadratic equation. Take the square root of for both sides is x minus 4 equals square root of 3, or x minus 4 equal minus square root of 3. Now, like last time, we add 4 for both sides because I need the value for x only. I add 4 for both sides. This cancel out. You give me 0. Now the final answer is x equal 4 plus square root of 3, or x equal 4 minus square root of 3. How did we get the positive 16? How we get the positive 16? Yeah, this one. You ask about this one?
Yes.
This 16? Yes.
Yes.
So I get this one from this, the blue one. Minus 8 over 2 square is minus 4 square. And minus 4 square is minus 4 times minus 4. And this is equal 16 positive. I put it here. And the same thing here. Minus 13 is the same thing, adding 16 for both sides.
Wait,
Yes.
when we get like questions like this, do we have to do the quadratic formula, or can we just complete the square?
We should, if the question asks you complete the square, you should to add this one, and you solve it by the simple quadratic equation.
Oh, okay. So if it doesn't say complete the square, we just
Exactly. You can use any way you want. If I did not tell you the way you have to use, you can use the quadratic formula, you can use the factoring, you can use any way you want. But if I specify in the question, you have to use the complete of the square, you have to use this step.
Okay, thanks.
Any question for this example? So this is the last thing for this section 1.4. Solve the quadratic equation by completing the square is the last thing in this section 1.4. So in this section, we learned 3 ways how to solve the quadratic equation. The first one is factoring. Second one is by using the quadratic formula, and we talk about the discriminant. Then the last one is the completing the square by adding for both sides. First of all, we have to move all numbers in one side and the variables in the other side. Then you have to add for both sides b over 2 square. The b is the second term, or you can say the b is the coefficient of x. The coefficient of x over 2 square. Then you continue solving the quadratic equation by the way we learn in example, the simple quadratic equation, and you will get 2 different solutions. So the first solution here is x equal 4 plus square root of 3, and the second solution is x equal minus 4 minus square root of 3. Now we're going over the section for solving other types of equation. So after we learn how to solve the linear equation in B8, then we move to the section 1.4, a quadratic equation. Now 1.6, solving other types of equation. So by ending 1.6, we solve all types of equations. You have to know how to solve all types of equations. So let's go to the new section 1.6. 1.6, solving solving other types of equations. Solving other types of equations. So here, solving other types of equations. So first of all, the book start talking about polynomial equation. Any polynomial equation, polynomial equation. This is this equation, the polynomial equation, for any polynomial equation for degree higher than 2, like x to the power 3 or x to the power 5, is not a quadratic, is not linear. For example, if I have here polynomial equation, if I will start by giving example. So example 1, or example, solve the equation. If I give you equation like this, x to the power 5 equal 9x to the power 3. How we can solve this polynomial equation? First of all, this equation is not a quadratic. Why?
Because the leading degree, the highest degree is not 2, it's 5.
Exactly. The leading degree or the highest degree or the degree of this equation is not 2, it's 5. So this is not a quadratic. And at the same time, is not linear. Is not linear, is not quadratic. So this is like different other types of equations. So what we have to do, shop first.
I would subtract 9 x to the 3 on both sides.
This is correct. The best way here, we have to move all variables and numbers to one side, and the other side the same thing, equal 0, like quadratic equation. I start talking about in the quadratic equation, move everything to one side and the other side make it 0. So the same thing here, I have to subtract 9x to the power 3 from both sides. So this will cancel out here because 9x cube minus 9x cube, they give 0. Now here I can get x to the power 5 minus 9x to the power 3 equals 0. What is the next step? Shop?
The factors are, then you find,
Yes, we have to factor it. What is the factor between these two terms?
x to the 3
X to
is
the
the,
power 3. Yes,
is
this
the
is
common factor. And
yes,
then it's
it's the
x
common
squared, x squared minus 9,
Okay.
which is the perfect square. That's good.
Yes. So the common factor between the first term and the second term is x to the power 3. And here the remaining is x to the power 2. Why? Because x to the power 3 times x to the power 2, they give me x to the power 5 minus 9 only. What? This only 9 without x to the power 3, because x to the power 3 times 9, they give me minus 9x to the power 3. Close the parentheses, equals 0. Now, can I factor inside the parentheses x squared minus 9?
Yeah, it's a perfect square. So it's
This is called not perfect square, the difference of square.
Yes,
Yeah.
yeah.
right.
And what is the factor for x squared minus 9?
X plus 3 and x minus 3.
This is correct. X minus 3 and x plus 3. So I can factor now everything here as x to the power 3 times x minus 3 times x plus 3. This here, this parentheses and this parentheses come from this one, x squared minus 9. After I factor x squared minus 9, they give me two things, x minus 3 times x plus 3. And this is equal what? 0. Now, by using the zero product property, the zero product property here in the beginning of here, the zero product property said if I have two things times equal 0, the first one equals 0, or the second one is equal 0. So the same thing here, the zero product property, I'm going to use it here. If I have three things, A, B, C equals 0, so this means A equals 0, or B equals 0, or C equals 0. So by using the zero product property. Now we get x cubed equals 0, or x minus 3 equals 0, or x plus 3 equals 0. Now, what does that equal x? What's equal here? What's the value for x?
0.
0. X
Actually,
equal
it
what?
doesn't exist. Something like that. Like no.
Yes. Take the third root for both sides. They give me x equals 0. Or what? Here I have to add, right?
Positive 3 or negative 3.
I have to add 3 for both sides. And here I have to subtract 3 from both sides. Now here, after I add 3, they will cancel out. So I can get x equal positive 3. Or I can cancel the minus 3 for both sides. I can get x equal negative 3. And this is the final answer. So the first solution is x equals 0. Second solution, x equal 3. And the third solution, x equal minus 3. Any question for this? Okay. This is how to solve the quadratic equation look like polynomial equation. I get a question here from Eric. How did you get rid of x to the power 3? Here I take, yes, go ahead, Shop. What I did here?
So the common factor between x to the 5 minus 9x to the 3 is x to the 3, because The
Yeah.
numbers don't have a common number. It's only one. So you don't have to take the common number between 1 and 9. It's just 1. And then the next thing is the variables. The variables, x to the 3 is the only thing that's common.
Shop, your sound is not clear. I don't know. I can't hear you clear.
Can you hear me now?
Just it's not clear. If you can fix it, and if you can fix it and repeat what you said again.
Can you hear me now?
Yes. Okay. Go ahead. What you said. How we get rid from the power 3? This one.
The common factor, the least common factor, the least common factor is x to the 3 because that's the common between these two terms.
Okay.
That's the least common multiple, x to the 3. And then
Correct. This is correct. And I have another solution. Is Eric, you can take the third root for both sides, like the cube root. Like you can take the cube root for both sides. This cube root for both sides. The cube root for this one is give me x only. And the cube root for this one, the 0 is 0. So I can get x equals 0. Make sense? Just take the cube root for both sides. And this cancel out the power with the root. You can get x. Here, take again the third root for 0. They will give me 0. So here 3. Now other types of equation is fraction expression. So example 2, another types of equation is fraction expression. It's called fractional expression. So example, for this is solve. I have fraction 1, 2 equal 3. Here we have minus. Here we have equal. And this here 3 over x. Here 2 over x minus 3. And here I have minus 12 over x squared minus 9. So to solve a fractional expression, this is first of all is not linear equation and is not a quadratic equation, is a fractional equation or fraction expressions. So to solve something like that, I prefer to move everything to one side again, and the other side is 0. Okay, so moving everything to one side, I'm going to add minus 12 over x squared minus 9. So they cancel out here. And when I add it here, they will be positive 12 over x squared plus minus 9. So again, the solution here, moving everything to one side and the other side, keep it 0. So here this.
I have a question.
What's your question?
So are you gonna end up cross multiplying at the end?
Yes.
Then you might as well not move.
I will use the cross multiply and I will use the least common denominator. I will show you.
Yes, so isn't it easier if you just find the common denominator right now, so you don't have to move this back again to cross multiply?
I will show you how I can do it. Okay. So I move everything to one side and I keep the other side equal 0. Now to solve this, I prefer when you have 3 fractions, just combine these 2 fractions, and the answer of this one combine it with the other fraction. So to combine this fraction, because I want to get one fraction only, like this, plus fraction, I prefer to use the least common denominator, or you can use like cross multiply. But here, the denominator is simple, is over x, and here we have over x minus 3. So I prefer the cross multiply. We don't have to find the least common denominator. We can find the least common denominator when the denominator is more harder. We can factor it, like this one, for example. So I'm going to do cross multiply for both sides. 3 times this minus x times this over this times this, the denominator x times x minus 3. Make sense, Shop? So here I have fraction plus fraction. So this one, 3 times 1, 3 times x minus 3 minus 2 times x over x times x minus 3. Here the sum goes down, the 12 goes down, over x squared minus 9 equals 0. Where did a plus come from? Which plus do you mean? This one? Eric? Yes. So this value here, it's negative 12 over x squared minus 9. So actually, I add 12 over x squared minus 9. Why? Because when I add this value, I get 0. Minus 12 plus 12 is 0 over the denominator. 0 over the denominator, they give me 0. So I cancel out this side. Then when I add it to this side, I have to add it to this side, like I said, because I want to move it to this side, to the right, to the left side. So actually, I add for both sides plus 12 over x squared minus 9. And here I have another student, they answered your question. The plus come from when he borrow the minus 12 over x squared minus 9 over. This is correct. So when I want to move this side to the other side, I have to add. Why? Because actually this number is negative. How I know? Look to the numerator. It's negative 12. So I have to add the 12 over x squared minus 9. Now I combine these two fractions, I get 3. I have to distribute the 3 inside the parentheses. I get 3x minus 9 minus 2x over this fraction, over this expression. The expression is, I keep it the same thing. I don't have to multiply. X times x minus 3 plus this one goes down again, 12 over x squared minus 9. I can simplify this side again. 3x minus 2x, what I get? What I get when I do the 3x minus 2x? They give me x only. 3x minus 2x is x minus 9. So I'm going to remove here everything, and I will write x minus 9. And everything here equals 0. Now, this step, I want to combine these two fractions together to get one fraction. So my goal is to combine all the fraction. I combine these two fractions, I get one fraction. Now I combine the both of the fraction, I will get another fraction, one fraction.
Don't you have to?
Yes, go ahead, Shop.
So if you notice, the first the denominator of the first set of fraction, x times x minus 3, that is simply x squared minus 3. And if you multiply to get, don't you have to get same denominator with x minus 2, x squared minus 9? So you just multiply that by 3. No,
Yes.
to get the same denominator, and then you can add both expression on the top with the bottom, and then solve for
This is
it.
correct. This is correct. So my goal right now to make the denominator are equal. So to make the denominator are equal, the best way is to use the least common denominator, easiest, then cross multiply. I will not do cross multiply because I have here x squared minus 9, and here I have a huge expression. So I don't want to like take a long time for multiplying. So the best things here to use the least common denominator for both denominator here in this two fraction. So the least common denominator. So what is the factor? The factor of x times x minus 3. What is the factor of this one?
X minus 3?
Yes, x times x minus 3. Is the same. It's factor already. We cannot factor it more. Is x times x minus 3. And what is the factor for x squared minus 9?
X minus 3 times x plus 3.
Exactly. So we go to the denominator for both a fraction and we factor it. This is the least common denominator. Now we cancel the common factor. What is the similar between this and this?
You can cross out the x minus 3.
Exactly. We can remove this from both sides. Now we go back to the fraction and we multiply. We go back to the fraction here, this one, and we multiply both numerator and the denominator by what's remaining of the factor of x squared minus 9. So the remaining of the factor of x squared minus 9 is x plus 3. So we have to multiply this here by the both side by x, multiply both sides by x plus 3. Multiply this here by x plus 3. And here the same thing, x plus 3.
No, but then you get different. Hold on, sir.
Yes, go ahead.
But you see, there's 3 x's. That gives you x to the 3. Don't you just multiply the Don't you just multiply by 3, because that gives you, because this is already x squared minus 3, and then if you just, because there's 3 x's, no, that's gonna give you x to the 3rd power.
X squared minus 3, they give me, no, they will give me, if I want to distribute the x inside, they will give me x squared minus 3x.
And then if you multiply that x again, that's x to the 3, no?
No, this is
We're gonna
not correct
multiply by x.
because if I want to distribute the x inside the parentheses, I will get x squared minus 3x. And this is not the same like this one. This is not correct if I multiply by 3. If this is multiplication is x squared, if I want to distribute the x inside the parentheses, I will get x squared minus 3x.
Yeah.
And if I want to multiply this by 3, I will get 3x squared minus 9x. And this is here is not the same like this. I want to make the denominator are equal.
But you see that isn't this gonna make x to the 3rd power, because x times x is x squared, and then you're multiplying x plus 3 again with the x squared. Doesn't it make it to x to the 3rd power? Just a little confused.
But we have like a
I wish.
x remainder that we have to
Hold
multiply
on.
by x. And
Hold on, Shab. I did not finish. I did not finish both. I did not finish multiplying. Hold on. So I will show you just step by step. So here we multiply the numerator and the denominator by what's remaining of the factor of x squared minus 9. So the remaining is x plus 3. Now the other fraction, we have to multiply both sides, but by what's remaining of the factor of x times x minus 3. The remaining here is x. You see the x, this one? We have to multiply now both sides by x. So multiplying this by x and multiplying this by x. After we did this, the denominator will be equal. 100% will be equal for sure.
Yeah, now I see it.
Now the denominators are equal. So let's continue solving the question. So now I will get, after I did this, x minus 9 times x plus 3, x minus 9 times x plus 3. This is the first fraction. So I will make everything to one fraction because we combined all of them to one fraction. Now the denominator are equal. X times x minus 3 times x plus 3 is the same like this one. Why? Because this here, the denominator here, if I want to multiply, this is equal. This equal here. This is equal x times x squared minus 9. And the same like this, x squared minus 9 times x. So the denominator for both sides are equal. So x minus 9 times x plus 3, here 12 times x. So plus, this is plus 12 times x. And the denominator is x times x squared minus 9. This is equal what? 0. Now, to solve this, now after we combine the fraction here, and then we combine the two fractions, we get one fraction. Now to solve this one, we cross multiply. And after we cross multiply, I will get only the numerator. So x minus 9 times x plus 3 plus, this is 12x equals 0. This is the only thing I have to solve. Now let's distribute everything and simplifying everything. Here, after I simplify everything and distribute everything, I will get here x squared plus 6x minus 27 equals 0. So here you have to distribute the x inside the parentheses and the other x with the 3. And again, you have to distribute the 9, the minus 9 inside this one. After that, you combine it with the 12x and you will get this thing, x squared plus 6x minus 27 equals 0. Now, to solve this one, we have to factor this one. What is the factor for this? X squared plus 6x minus 27. I'm looking for two numbers. The multiplication is minus 27 and the sum is 6.
Plus 9 minus 3.
Exactly, x minus 9 and x plus 3 equals 0. Now by using the by using the zero product, this equals 0 or this equals 0. So x minus 9 equals 0 or x plus 3 equals 0. Again, we add 9 for both sides, I get x equal 9, or I subtract 3 from both sides, x equal minus 3. So this is the solutions for this fraction. Now you have to check, because if you have to check this is correct solution or not, you have to plug x equal 9 inside the fraction and you have to plug x equal minus 3 inside the fraction. So let's take x equal minus 3 to plug it inside the fraction. Here is, hold on, here is positive, here negative, sorry. Here's negative. This is not correct. Why? Because 9 plus times minus 3 is minus 27 and the sum is positive 6. Here the same thing. Here positive, so here's negative, and here is negative, and this is positive. Now when you plug the 3 inside the fraction, I get 3 over 3 minus 2 over 3 minus 3. This is 0. equal minus 12 over 0. And this is undefined when you plug the 0. So the 0 is not a solution because I get here 3 over 3 is 1 minus 2 over 0. 2 over 0 is not a solution. Is undefined for this fraction. So this one is not a solution. Now, after you plug in x equal minus 9, you will get answer. So this is a solution. So the only solution for this fraction, the solution is x equal minus 9. This is the only solution for this one. Any question for this example? Why again? Okay, so I get question why the 9 is this one is not a solution. When you plug this one inside the fraction here, I get 3 over 3 minus 2 over 0. 3 minus 3 is 0. So they give me undefined. So I have to stop. So this is not a solution. But when you plug the other solution, the 9, 3 over 9 minus 2 over 9 minus 3 equal minus 12 over 9 squared minus 9, they will give you a solution. I mean, not minus 9. Yes, the minus 9, if you plug the minus 9, they will be everything fine. Will not be any problem or trouble. But if you plug the positive 3, they will not give you a solution. They will give you an undefined here fraction because I can't divide any number over 0. So undefined. That's why here the 3 is not a solution, but the x equal minus 9 is a solution. This is my only solution for this one. Okay, any question for this example? Make sense? No questions? Okay, if no questions, we're going to stop up to here today. And I will see you next Thursday on Zoom again. And have a good day, everyone. See you Thursday.
Bye-bye.